Let's see here. So we have a few, let's see here. Okay, so this is our community series where we go past the slides and into real practical use cases, how people are actually building with data and AI. And today is a good one. We've had lots and lots and lots and lots of requests for sports analytics. So welcome, sports fans. I know that's cheesy, but I'm going to say it anyway. And if you don't work in sports, this is still a good place for you to be. The story here is really about turning any organization with tons of high volume, high velocity data and turning it into like decisions that are fast enough to matter. And sports just happens to be one of the most demanding versions of that problem, with raw tracking feeds coming in and teams needing real-time insights, all the good stuff. So wherever you sit in the industry, you'll see your own data challenges in this. So a couple of quick notes on how today's going to run. The format's really simple. Our speakers are going to present for the first 20, 30-ish minutes, and then we'll open it up for Q&A at the end. Drop your questions at any time into the chat as they come to you, and we'll collect them there and get to them in the order that we put them in as soon as the presentation wraps up. And as I mentioned, this is being recorded, so we're going to share the recording with anyone who registered. So no worries if you need to step away or if you can only come for half of this, we'll have a recording sent to you. And if you're not already part of the Databricks community, please join us. Community.databricks.com, register today. It's the best place to get help from experts for free. And we have a very high, I think it's a 2.5 hour response time. So very excited about that. We're growing every day, over 200,000 members of SMEs to help you out. So now I'm going to stop talking about community stuff, and I'm going to introduce two amazing folks from Databricks who absolutely live in this stuff every day. We have Nick Raganese, a solutions architect here at Databricks, and Kush Patel, also a solutions engineer. So they're going to walk us through how a unified data platform takes you from raw feeds all the way to real-time decisions with the demos to back it up. So I'm going to step aside here, and my co-host Tushar and I are going to hand this over to Nick and Kush to dazzle you guys with all of this awesome sports analytics stuff. So take it away.
Awesome. Thanks, Mandy. Hey, everyone. I'm Nick Raganese. I'm a solutions architect here on the sports team at Databricks. I've been here at Databricks for about 5.5 years, focused on sports for 3. I'm joined by Kush. Kush, you want to give yourself a little intro?
Yeah, hey everyone, Kush Patel here. I'm also a solutions architect on the sports team here at Databricks. And yeah, I've been here for a little over a year now.
All right, perfect. Appreciate everyone joining. So we're going to dive into how we're using data and AI to drive our use cases within the sports industry here at Databricks, how our platform helps teams win games, as well as have a better understanding of what is going on within their arenas, outside of the arenas as well. I'm going to give a quick overview about just the general landscape, how we think about sports use cases within Databricks, and then Kush is going to dive deep into a demo for soccer, which is very timely. It was awesome right around the finish of the World Cup. So for starters, I assume everyone who's joining here knows what Databricks is, so I'm not going to dive too much into it. I just like to highlight that we were the pioneers of the lakehouse vision. So the idea of taking your data lake and allowing it to power machine learning use cases, as well as your data warehousing types of use cases with one single source of truth in that data lake. We've continued to expand upon that, moving into OLTP and other use cases that I'll dive into. I think some really important open source software, though, has come out of our company. Delta Lake, that is the storage format that sits on top of your data lake and empowers all of this. MLflow, the end-to-end tracking for machine learning models. It is an open source package that you can monitor your models from the development phase into putting them into production, monitoring in production, as well as iterating upon those while they're in production. As well as Apache Spark. So Apache Spark is how we really got our start. Our founders were the original creators of Apache Spark. It is still the best-in-class big data ETL framework that is out there. Even our largest competitors all use Apache Spark, and we've continued to expand beyond that. And those open source components are really the foundations of what have led to these really impressive numbers here that you see on the screen. In sports, we have some really impressive stats as well. 2 of the last 5 World Series champions, 2 of the last 5 NBA champions, We've seen awesome improvement in winning percentages from our NFL teams who adopt the platform. And then you can see there we have some other metrics just in terms of our general coverage within sports. This is just the major sporting leagues in the United States. We also have sports customers in Europe, some teams within the Premier League, within La Liga, as well as some F1 teams as well. So we really have customers across the globe who are using Databricks for sports analytics. In terms of the industry trends we see that kind of shape how we approach and tackle sports problems at Databricks, the number one is fragmented tools. And this is one of those things that applies regardless of what industry you work in. As AI continues and people continue to have a variety of different tools, whether it be different platforms for doing data analytics, doing data science, and building chatbots, or just different models out there that you're using. One of the biggest challenges that customers come to us asking for help with is dealing with those fragmented tools, having a single source of truth, having as much of a single platform as possible to integrate with all of those different tools and platforms. Pressure for real time, that's obviously kind of the focus of this talk, but we're increasingly seeing the desire for sports teams to have real-time information. So particularly with the rise of biomechanical data sets like Hawkeye, which I'll talk about a little bit more, but the biomechanical data that is within a lot of the major sporting leagues, teams are increasingly coming to us asking for real-time insights, not just during the game, but even play by play, trying to make decisions as real time as possible with their data. On the athlete side, we see a lot of changes over the last few years in terms of how athletes view themselves, be it their kind of holistic view of how they perform as an athlete, right? It's not just about what they're doing during the game, but what they're doing in the practice facility, what they're doing outside of the facility, how they're recovering, the food that they're eating, just having a better 360 view of how they're performing and what they're doing and how it is leading to their performance. And then the final piece that we frequently hear from teams and leagues is challenges with data sharing. There's a lot of data sharing between leagues and teams. There's also a lot of data sharing from teams to their partners. Think about any marketing partners that they have, any vendors that they utilize. So being able to efficiently share that data to help power those real-time insights is a challenge that we're often looking to tackle for our customers. So we know that teams and leagues that embrace data and AI are going to have a competitive advantage. We have seen it firsthand. But oftentimes organizations are continuing to struggle as they want to adopt AI particularly. So the way that we think about this and how franchises are becoming more mature with data and AI, we have this data and AI maturity curve. I think everyone has seen some version of this where you have on the y-axis your competitive advantage, and then on the x-axis is how mature you are in terms of data and AI. And oftentimes we see that teams are here coming to us saying, hey, we have a lot of Excel reports, we have BI tools, dashboards, and data warehousing, but really we want to get here. We want to be using as much generative AI and agentic AI as possible. We want these to be as autonomous as possible, making decisions on their own if it is possible, but if not, at a minimum, providing real-time insights automatically to our coaches, to our front office, so that they can, as quickly as possible, learn what the AI is recommending and make a decision off of that. The challenges that we see, though, as teams are trying to move along that data and AI maturity curve, for starters, connecting AI to the data is difficult. We've seen this in particular where most of these agentic models at this point can pretty much tackle any task that you throw at them. The real challenge is, do they have the data and the context that they need to tackle that problem? So that is a big focus point for our team and for Databricks as a whole, is ensuring that agentic AI models that you are utilizing have the data, have the context that you need so that they can answer those questions to the best of their ability. Another component, controlling AI and the data usage is more critical than ever. So whether it be access to data itself, you don't want an AI agent to be a sort of like backdoor to any users having access to information that they shouldn't have had access to, or just general monitoring who is using these models, whether it be your internal stakeholders or models that you are utilizing to surface insights to fans directly. Optimization of costs is increasingly becoming something that we're seeing as well. These AI models are extremely powerful. They have solved a lot of amazing problems, but we are approaching, I'd say, a slight trough of disillusionment where costs are becoming a prohibitive factor for these models. And people are starting to ask, are they getting the correct ROI on these models? So at a minimum, we want to provide the tools and insights to understand where your spend is going, how many tokens you're spending, who's spending those tokens, doing what. And then you can start to make decisions around, is this the best return on our investment in terms of those costs for AI? And then even beyond that, just starting to do kind of better cost attributions, or maybe making more intelligent decisions on what AI models you're using, right? Generally, we follow that kind of principle of the simplest AI model for the problem is what you should use. And if you have an understanding of your costs, you can maybe have a better understanding of which models to use for which scenarios so that you can make sure that you are spending that budget most effectively. The final thing that we're increasingly seeing, the lock-in for these individual models and vendors. So we've seen that the best model 6 months ago is not the best model now, and it won't be the best model in a year. So that is why we integrate with all of the models out there. We don't want you to be locked into any specific model. We want you to be able to use different models as different models evolve. And even right now, if you have different tasks that you would like to accomplish with different models, we think it should be very easy to do that in one platform. We see this specifically in sports all the time. Frequently, we see Claude as the best-in-class coding agent for people doing general development work, but we see that Gemini performs much better for computer vision, which has a lot of use cases within sports landscape. So a lot of our customers utilize the Databricks platform so that they can utilize both of those models in different scenarios and route each problem to the appropriate model for a specific use case. And down the road, if a new model comes into play or you change which model is most effective at which task, you can be able to flip those out quickly. So all of that is what drives the design and problems that we solve with our data and AI platform. Just diving a level deeper in terms of what that infrastructure looks like under the hood. So again, we are built on all open formats. So be it Delta or Iceberg, with our uniform data format, they essentially integrate perfectly and you don't really notice the difference between where the underlying storage format is. And we also work on any of the major cloud providers. We integrate with pretty much any model that's out there, and any data that you are using can be integrated and analyzed with Databricks. It can be traditional structured data, free-form text, video data, audio data. We've done analysis on all of it and sometimes all of it at the same time for one use case. From there, on top of that open infrastructure, we have our primary development tools environments. So we generally break them down now as our platform has expanded into 3 core categories: Lakeflow, Lakehouse, and Lakebase. A lot of lakes, I know. But Lakeflow is our ETL framework for ingestion. Think about how do you get your data into your analytics environment, into the Databricks environment as quickly as possible so you can have those real-time insights. From there, Lakehouse is our bread and butter, where you actually do that real-time analytics, where you do analysis, ETL pipelines, building out machine learning models, even building out your own custom chatbots. The newest piece of our platform here is Lakebase. Lakebase is your transactional database. So this is our managed OLTP offering. It is a managed Postgres database. And the best part about it is it's kind of the true completion of the vision of the Lakehouse, in the sense that the single source of truth stays as your data lake under the hood, and all of these different processes pull data and put data back into your data lake. So if you think about using Lakebase as your OLTP database, what would happen is, say you have a front-end application that you give to your GMs and your scouts and everyone in the front office. On the back end, all of the analytics that your data science team does in terms of who are you scouting, who are the best free agents out there, which athletes should you be targeting potentially in free agency, all of that flows from Lakehouse, and we handle the flow that gets it into Lakebase so it can be served into your front-end application. On the back end, as GMs and scouts and coaches make decisions and decide, hey, we are going to go after this specific player, we're potentially going to offer them this contract, all of that data that gets written into the front end immediately gets synced back into the Lakehouse, so that's in the same environment where your back-end analysts are doing all of that analytics. So in that sense, we handle that bi-directional flow, so you don't run into that issue of having multiple different data sources and you're not exactly sure what your single source of truth is. On top of that, we have our governance layer. This is really the unsung hero of our platform. It's not the most fun use case to be talking about governance, but it's critical in terms of both the performance of any individual models that you have and also any sort of legal restrictions that you have, and making sure that you don't have any sorts of data leaks or breaches or anything along those lines. So that is primarily broken into two components, our Unity Catalog and our Unity AI Gateway. The catalog is governance for all of the different assets that you have. So think about tables, files, actual models themselves, any tools and agents and skills that are a part of those models, regardless of what the data type is. You can govern it with your Unity Catalog and decide who has access to it. Any sort of fine-grained access as well. So you can get as specific as column level, row level, data masking, all of that. You can control all of that governance through the Unity Catalog. Working hand in hand with the Unity Catalog is our Unity AI Gateway. So that is more about the consumption side of things in terms of what models you have deployed, what external models you're calling out to, making sure you understand who's calling out to those models, what did they ask those models, how much money are they spending with those, and ensuring that those models are being used effectively and only accessing the data that they should be allowed to access. The next layer, which is newer as of our Data and AI Summit a few months ago, is our Genie ontology layer. So this is really the context component in terms of what agents and individual users need to make sure that they're making the best decisions with their data. So it's primarily broken up into two components, semantics, and then the learn knowledge with the knowledge graph. So on the semantic side, this is where you define your business metrics. Think about the KPIs that you're going to have internally. So for sports teams, it might be ticketing revenue, right? And ticketing revenue may have a very different definition depending upon if you're looking at a game, a playoff game, a concert, different types of suites versus if you're courtside versus if you're in the upper deck. All of those have different calculations on how revenue works depending upon the agreements that you have. And so the semantic layer is an open layer where you store those definitions so that any other users can access them and understand those definitions, but also your agents can access them. In terms of the ontology and the learn knowledge component, we have automated knowledge graphs that understand the data that sits in your data lake. So think about the underlying relationships between these tables, joins, the definitions of those individual columns and calculations in your semantic layer, access patterns, right? You can make it helps agents make decisions around, hey, if you have revenue showing up in multiple tables, but one table gets queried every day and one table hasn't been queried for weeks, you probably want to make a decision when you're asking a question about revenue that you should use the more commonly accessed table. These two work together to create a very powerful context layer that we believe is going to be the future of agentic AI. So one specific example of where we have seen this, within sports, we frequently are trying to prevent injuries, right? And if you want to prevent injuries to players, there's a lot of different data that goes into it, and it's different data sets. So you have actual medical reports, you have video of the play where they might have been injured, you have audio from the announcer identifying that somebody came up limping. You have the biomechanical data, so the XYZ coordinates of the players and their different limbs there. Ontology allows you to put all of that data into single models so that those models can understand the different contexts of those different data types to help achieve any goal in terms of trying to prevent injuries and identify players at risk of injuries. The final layer on top of that is our Databricks layer. This is where you actually develop your own agents that are customized for specific tasks within your organization. On top of that, we have our new Omnigent offering. Omnigent is a meta harness that can call out to any of the major models that are out there. So if you think about my example earlier, where maybe you want to use Claude Code for your general coding assistant, but then you want to use Gemini for the video analysis capabilities of it, you can call out to all of those different models through Omnigent, and you have one single UI through which you can call out to both of those models, and you can understand all of the different users and how they're interacting with those different models. And the best part is you don't necessarily need an agreement with each of those model providers. Databricks has agreements with the providers. We have our own hosted endpoints for each of those models, so you can use those models directly through Databricks without going out to each of the individual model providers and getting your own agreement with them. But then also, if you do have existing agreements with those model providers, we can set up Omnigent so it's calling out to your existing endpoints that have been spun up by those model providers. The final piece of it is the agentic apps that live on top of it. So that is your actual dashboards, custom applications that you're building. And we are increasingly expanding our capabilities, be it into the cybersecurity space with LakeWatch or into the CDP space with Customer Lake. So I'm going to leave it at that in terms of the underlying platform. Kush is going to dive deeper into this with his example. But I just wanted to briefly highlight a few examples of how we are doing this within the sports industry. And then Kush will do a deep dive with that soccer example. So when we think about use cases with our sports teams, they generally fall into one of three core categories: player performance and health, helping teams win games, making sure players are healthy; fan engagement, making sure fans are having a positive experience at the arena. It is a business. There is a certain amount of driving fans to buy more tickets, buying fans to buy more merch, more hot dogs, etc. And then valuation and program growth is kind of the wild card that we're increasingly seeing. Particularly when you think about college sports with NIL, it has completely revolutionized the way that colleges have to think about each of their teams, their general athletic department. So how they're going to approach those operations is key. And then also on the traditional professional side, right, where a lot of these teams are owned by ownership groups that own multiple teams, that own their arena as well. And they're trying to understand how to use AI to drive those optimizations and drive the broader operations of that organization. So for one specific example in terms of how we are using Databricks for data intelligence here. So we have AI-powered computer vision components that can be integrated within the Databricks platform. So this is the Hawkeye data set that I had alluded to. It might be a little small for y'all, but it has these little stick figures that show the XYZ coordinates of 27 measures of the players. And I think there's about 60 measures per second. And in addition to making cool visualizations, you can get a lot of awesome insights in terms of player performance and player health. So for starters, you can build out an expected field goal metric, for example, within basketball. You can use these defensive pressure metrics, the closest defender, closest hand to the ball, vision blocked, how much a hand is blocking the face of the shooter. And you can use all this to help build out a field goal percentage to understand which players and which plays are getting you the most open shots. When you dive into it deeper, though, with player health, this gives us the capability of understanding more in-depth biomechanics as well, right? So we have some shooter mechanic metrics down here, again, which might be a little small, but we can also dive into the player health components of it. Think knee flexion, ankle range of motion, any sort of early symptoms that a player might be at risk of having an injury, and trying to bring alerts to teams so that they can potentially sub that player out or give that player a rest game before an injury happens. Another frequent use case that we see are chatbots for coaches to help prepare for games. So think about scouting reports for opposing teams, or an at-bat assistant where you have the data around the opposing pitcher, what pitches they throw in what scenarios, how they perform against your specific batters, maybe batters that you might want to pinch hit, potential pitchers that the opposing team could bring in the middle of the game. All of that type of analysis to help coaches understand how they can prepare better for their upcoming game against the opponent. We also have a very similar example with this within football, both of which we have blog posts on, but the same idea for a defensive coordinator, right? Helping them prepare and understand what plays does a coach tend to run in different scenarios, be it on first down, third down, first and short, goal line plays, which packages they run, which players they tend to target in those scenarios. Having a chatbot that can be an assistant to those coaches so they can better prepare for those games. Another thing that's frequently coming up for us is draft simulation. So these are generally Monte Carlo simulations under the hood, but draft day runs and happens extremely fast. So it's very powerful for these teams to have an application that they can use that enters what was the actual draft pick, who was taken, and then you can quickly run a simulation on, well, who is likely to be available when we're drafting, and maybe help them make decisions in terms of player valuation and pick valuation if there's any interest to trade up or trade down. The final piece is more on the business side. So we have our Venue 360, just understanding who is coming into the arena, where are they in the arena, potential alertings around any issues with the facilities, maybe if there's any shortages of beer, hot dogs that you need to quickly send additional supplies up, or if you want to route fans to a different station, all of those capabilities in real time available through Databricks. Additionally, the fan 360 view itself. So really diving into, well, who is at the game? What games have they been at? What type of fan are they? How can we ensure they're having the most positive experience and potentially remarket to them? And then building out chatbots on top of that. So after the game or before the game, having a chatbot for your marketing team so that they can understand who do they want to target, what campaigns do they potentially want to run to ensure that you're getting the best fan experience. So those are just some of the examples of what we were doing within sports. But with that being said, I'm going to pass it over to Kush to dive even deeper into our example in soccer in celebration of the end of the World Cup.
Cool. Thanks, Nick. Yeah, let me share my screen. All right. I think you all should be able to see this. Cool. So Nick just gave you the big picture around Databricks Sports, but I want to bring this to life through an example that we built. So picture this, right? Let's say you're on the technical staff of a national soccer team at this year's World Cup, right? You just came off of a match and you're getting ready to play your next opponent in about 48 hours, right? So your job is two things. First is to deeply examine the game you just played, but second, to also build a plan for your next matchup, the one that's coming. So normally the tools that you need to do this analysis could live in about a couple different places, right? You might have a video system, a stats provider, some spreadsheets, maybe a scouting database and so on. But with what we've built here with Databricks, right, you have all of this in one spot, in one platform, right? So let's say on Monday, right, you sit down to review the match on Databricks, right? Here we have the whole game rebuilt from the tracking data, right? So you can begin to work from here. So first, right, two things are already drawn for me, right? The first is the tail, right? We have a ball trail where the ball is just traveled, and we also have a player path, right? The run the man in possession is making. So straight away, we're already watching how we circulate the ball and how we get up the pitch. Right, so now I can start drawing on this. Right, so adding in some home lanes. Right, these are the passing lanes open to whoever's on the ball, right, in that exact moment. Right, and this is where you can start to find your team's problems. Are we giving him some options to play forward, or is the opponent screening, every forward lane and forcing us back? Right, we can start to draw these insights. Adding in a hole, right? This shape is our block. Right, this tells us how compact or how stretched the side is. Right, a tight block is hard to play through, but when it balloons open, that's the space we're giving away, right? I can add in a couple more things, right? The shape and the control, right? Shape gives me our centroid and defensive block, and the pitch control shades exactly who dominates each zone of the grass, right? So this is the argument you can make to the coach. Like, for example, we own the middle third, but got pulled apart in the wider areas. Right, and notice what I'm doing the whole time, right? I'm scrubbing through this live, right? I never loaded the whole match. That would be too much data for this browser to handle, right? But the app pulls one small window of frames at a time, and it comes back in a couple milliseconds, right? So this is running on that OLTP database that Nick was referring to, right? Called Lakebase. Right? This is what makes this 25 frames a second replay start to feel instant, right? As an analyst, your next job is to pull the numbers up. So let me touch on the analysis tab. Right, so you have access to a shot map with expected goals on your chances. Right, you can have a passing network, a heat map, and some set pieces. Right, so this is the full match broken down, however you want to slice it. The one thing worth calling out here is that this is all reading from the exact same data you saw before. Right, I didn't do any new exports or no, new overnight jobs. This is all computed once and stored in a single copy of data. Right, and this is served instantly to your surface. Right, in this case, I have this app. Right, and this makes your whole engineering team more efficient and reduces your cost of value. Cool. So we've reviewed the game. Now switching to planning for the match that you're gearing up for, right? We have our scouting system here. So if I click on a specific athlete, right? Let's take, Pedro right here, right? We can see their profile with a style radar and a pass sonar, right? So these can give you insights on directions they like to play and their playing style. At the bottom piece, this gives me a list of the closest matches to this player anywhere inside of our data, right? So this is built on Databricks vector search, right? So every player's season is written up as a scouting blurb. It's indexed and it's kept current automatically. So there's no separate vector database that I'm managing, right? Our Agent Bricks product automatically manages this for you behind the scenes. And if there's a specific question that's not already answered here, right, we can just ask for it, right? So let me ask for, how does Brazil press? Okay, cool. So it responded with an answer. So what's actually happening here behind the scenes, right? We have what we call a Genie room, right? So I pointed Genie at a specific group of tables, gave it a little bit of context around the sport, like what does expected goals mean, or how we define a press, and it answers back in plain English. Right, so this is writing some sort of like governed SQL against my data, right? So my non-technical scouting staff, right, those that don't know how to write SQL can start to search through your entire data ecosystem that you have for the tournament in their own words, right? And they can start to self-serve on this data. So I'll show you how this works under the hood when I get into the platform, but yeah, that's the scouting piece that we have here. So moving on to standings. This is a view backed by those same tables, right? This is a scatter of every nation's attack, right, against their defense. So I can quickly see whether my opponent can beat us by outscoring or by shutting the door. Next, I want to highlight what we have for our agents here, right? This is the part that used to eat up 1 to 2 days of your staff's week, right? But here I can just pick the team that we're playing next and ask it to build a scouting report. Right? So if I generate a dossier here, watching on the left while it's working, right, we have a multi-agent supervisor, right? It's orchestrating a few specialist agents. So we have a tool calling agent that goes and pulls the opponent's tracking metrics and their scout signature. We have a knowledge assistant that's answering from the tournament's history and reports. And this is all being synthesized by a Claude LLM that we've hosted on Databricks model serving. Right, so there's like an extraction agent that's turning the raw match into a structured match report. And you can start to see, some of these building blocks at play here, right? And how they're coming together and being orchestrated to provide a grounded answer backed by our real data. Right, so here's what, what landed, right? So we have information about how they press. We have a visual representation here, right? Some information about their vulnerabilities, key players to look out for, and a numbered game plan on the bottom, right? So this is real grounded data that you can hand the coach, and it allows you to get, a tailored strategy grounded in the data that you've collected and gathered, right? So you can start to see how this can be a really powerful tool for you. So looking at the architecture under the hood, right? I know Nick touched on this, briefly in his presentation, but walking through it and how this applies in this specific scenario. Looking at the bottom, we have all of the different feeds, the game feeds that are coming in, right? So we looked at the tracking data, match events, those player profiles, right? We're storing all of this in an open table format inside of your cloud environment, right? So let's say you're using, AWS and you have S3, right? So we'll store the tables in a Delta format inside of your bucket there. And what this means is this gives you ACID-like properties to your structured, unstructured, and semi-structured data, right? So that gives you a strong foundation for data ownership for yourself, but also scalability as you start to work on these heavier workloads. Right, we're bringing the data in via Lakeflow when we're organizing this inside of a medallion architecture. Right, so bronze, silver, and gold layers. Right, getting those tables cleaned up and ready to serve to the downstream layers. Right, and this can be accessed in a couple of different ways. Right, real-time queries via the Lakehouse. You can sync this to an OLTP Postgres database called Lakebase, and that gives you those faster reads and writes for your application layer. And we can also start to organize this into a vector search for those granular lookups. And once you've built that foundation, you can start to unlock, several different use cases on top, right? So I just walked you through our Coaches Corner app. We have agentic work that can be done by Genie, right? That's your text to SQL, answering questions using plain English, and also some, coding assistance as well. And then finally, you saw an example of a multi-agent supervisor using Databricks, and how you can start to orchestrate all of those different, tool and LLM calls. And we can also make this accessible via an AI BI dashboard, right? So once you have the data organized and ready to go in the catalog, you can start to, visualize this with relatively low lift. So this is an example of the architecture. I wanted to show you what this looks like inside of the Databricks workspace, right? So jumping to our catalog tab, right? This is our governance layer that's backing our entire infrastructure for the app, that I just showed you, right? So we call this Unity catalog, right? It's one catalog that stores, all of the information for your soccer team here. Right, if I take a look at a specific data set, right, on the left-hand side, you see that we're inside of the player biometrics data set. I can view the sample data, right? And this gives me a quick snapshot of all of the rows, columns that went into developing the view that you just saw. Right, if I click on permissions, this is where you can start to assign permissions for, who can access this data, right? And this is not only for your human permission privileges, like, for myself or Nick, if I wanted to go in and query this data, but also for your non-human users, right? Because you have agents that might be crawling these data sets, or if you have an application that wants to access this, right? All of these permissions are set in the same spot, right? We also have a lineage view as well. And this is an example of, how your data is being queried or updated downstream and upstream, right? So if I pop open the lineage graph, you can see the raw tracking files flow in on the left-hand side. And this goes into, our database and the app side. So this is in one picture. You can see how all of your, data assets are connected with one permission set over all of this. I didn't draw this. Databricks automatically tracks this for you and starts to build that semantic layer behind your entire soccer team's data. Right? And this is automatically crafted for you. And with some tuning, right, we can get this dialed in to your exact needs based on what you're looking at building. So how does all of this tracking data get organized into these clean tables? Right, so we have a pipeline that's powering all of it. So looking at the shape of this, right, we have 19 raw feeds coming in from the left, and through a cleanup layer in the middle, we're able to curate this into some cleaned tables on the right-hand side that are ready to be queried. So the difference here, and the cool part, is that nobody wrote a single job to move these data between these boxes, right? We declared the tables we wanted, and Databricks worked out the order, the retries, and the infrastructure, right? So we call this product SDP, Spark Declarative Pipelines. Databricks automatically manages and parallelizes all of the Spark infrastructure and builds the pipelines for you so you can get the exact output you defined, right? This is serverless. I didn't have to size the cluster, and it's incremental. So for the next match, we only have to recompute what's changed. So this saves you a lot of time and money. And this obviously leads to trusted numbers that you can hand to your coach. On the app side, right, this is the app interface of how you can start to build and serve apps inside of Databricks. So clicking on the app that I just showed you, right, it's available here at a URL that is ready to go, right? So I didn't have to maintain a separate server that's siloed elsewhere. The app runs inside the workspace, right? It has its own identity, and login and authentication is already handled for you. So this app lives inside of the same governance boundary as your data, right? It only sees the tables that I granted. The last spot that I want to highlight is the supervisor agent. So if you recall, I typed into the Scout chat, to create a plan for our matchup with Brazil. So this is where it actually went, right? This is the Genie space behind that room, right? So I pointed all of these tables, right, that we were looking at inside of the catalog and assigned it to this Genie space. I also gave the space some instructions and context around the sport that we have here, right? And then using this information, it's able to answer inside of plain English, right? And you saw that answer, surfacing up on the app. And the part that I love the most about this is the monitoring, right? So every question anyone asks, lands here. So the question that I asked live a couple of moments ago should appear here inside of our traces. And if I click on this specific request, we can see that this is not a black box. It's observable, and you can see the exact model output that was produced, that we parsed and showed inside of the app interface. Right. So once you get like significant sample size of what your coaches are querying for and what they're looking to extract, you can start to tune and train this internal plumbing to give you the answers that you want at a higher quality to your end user. Right. So this is a truly customizable workflow that you can use for your needs for your team. Right. So taking a step back, I know we touched on a lot of different things from the app to agents and the exact architecture behind how we're using this to power a platform for a World Cup soccer team. I hope this was valuable and you're able to get some color to the presentation that Nick gave. So with that, I'll give it back to Nick to take it away.
No, I think that's it for all we got. Looks like we've got some time left for questions if anyone has them.
Great. Yeah. Let's see. We have had some really awesome comments. I haven't seen any actual questions, but everybody's just going this is sick. This is the coolest thing I've ever seen. But there's one comment I love from Josie. Imagine if Billy being the GM for the A's in the 90s had these tools when he had changed the scouting strategy using data and stats, which was a game changer then. Imagine if he had this then. Which is just hilarious. Yeah, I mean, I don't see a ton of questions here in the comments, but I would really encourage you and Nick and Kush to go through here and look at some of these. Oh, we have one right now. When streaming live tracking data for immediate AI decision making, how do sports data teams balance the need for low latency with data quality and governance?
Yeah, it's a good question. I think the approaches generally always start with a batch model to understand the different iterations, particularly with the Hawkeye data set, for example. There are basically 3 or even 4 updates in terms of the initial stream, post-game, and update. And then oftentimes, as much as a week later, there'll be kind of a final confirmation. So starting with batch and understanding the relationships between those 3 different updates and as they come in is a great way to get there. And then you can kind of understand, hey, we know these are the types of weaknesses that occur in real time if you're going to stream that during the game. And then it can help you kind of make the decisions around when to trust the data in real time versus when it might be a little bit riskier.
Exactly. I also wanted to share a comment from my friend Matt, who says, now I just want to know how the teams that don't have this tech are scouting their opponents.
I think data and AI is a massive advantage in sports. I can't deny, but it is a game played by people in real time and coached by coaches. So I'm not going to take away from the fact that there's still some amazing coaches and players who are able to operate without it. But I think we could make their lives easier if they adopted it for sure.
Awesome. That's great. Cool. Well, yeah, I mean, I think this has been such an incredible talk, and art and science, right, Nick? Yes. So someone just asked if they can access the recording. Yes, the recording will be sent to everybody who registered for the event. And then Robert said, our total accounts executive this last week, I attended the NBA Data Forum. Everything that was innovative was being run on Databricks. Yes. That is what we like to hear. That is what we like to hear, because we are the most innovative company out there. That's right.
It's always fun when customers sell the platform for us. So
you know what? Seeing this, it's really, do you guys just hang out all day watching games? Because people just feels like they're just showing up to buy this. Then we had, here's one. What will happen if both teams are using the same scouting strategy of Databricks to play?
It's a good question. I think that's where I highlight, we are a platform for developing these data and AI models, right? There is still a massive amount of competitive advantage internally in terms of the data that you access, what you choose to use, how you monitor it, how you make those decisions. So by no means is it like we have this playbook that we bring to every single team. It's oftentimes kind of the opposite of we're trying to cater solutions to the individual teams. So we go to them asking them what problems they're trying to solve, how they want to approach these things. And so it's kind of like a nice double win of it's generally a more catered experience for the individual teams. And also there's not this concern of I'm bringing trade secrets to other teams. It's generally I'm a pretty one-on-one relationship where I just say like, hey, what are you trying to accomplish? Let's solve it for you. So the platform is super helpful and an advantage, but it doesn't offset, the thought process and the individual contributions that people need to make decisions on how to use data.
Yeah, Matt says they still need to know how to use the data, right? So any two tech companies who are running on Databricks apply the data to compete with each other, so it's the art and the science of it. Then we had another one, environmental conditions like stadium lighting, weather, or camera setups across venues can cause tracking models to behave unpredictably. So are there any ways that organizations can monitor and manage AI performance to ensure consistent insights on every game?
Yeah, I can take this one.
Yeah.
So yeah, I mean, I think generally speaking, right, there's going to be variability with any data source and how it's captured. But there's in that pipeline view I showed you, right, there's techniques that you can use to clean and interpret the data in ways where if there's bad data quality, we can have expectations that are set up to capture and sideline that data for further review in the future if that's manual or an automatic workflow that you want to put into place, right? Once you've captured enough data that's unique to your specific venue, you can start to train models on it and run inference, and you can then start to flag certain behaviors that are off base, right? And that example that Nick showed, right, with that stadium view, you can start to build a blueprint or a footprint for exactly how you can start to monitor your stadium in real time and start to throw those flags using AI, right? So it's a two-part answer, right? One is putting the right data cleaning practices in place, but then also once you've ingest the data, right, you can start to use AI to analyze and flag any of those areas where the data might be out of sync.
Yeah, and Josie made a good point that this won't replace humans in the loop. I don't think that's what anyone is intending to do. This is data that helps you make better decisions, that makes informed, intelligent decisions.
Exactly.
Which is, I think we can apply that statement to everything right now in the world. Let's not let AI take over every single decision that we make for ourselves. Not a healthy thing. Cool. All right, so unless there are any other last minute questions, I think we're gonna wrap it up. And I wanna thank everybody, wow, for hanging out and being with us this whole time. It's been amazing. As I mentioned, this recording will get sent out later on, probably tomorrow, as soon as it gets processed and posted. And we'll go to everybody who's registered. Thank you so much for coming. Thank you, Nick and Kush, for doing this. This has been a long requested BrickTalk, and I'm glad that we got it on the calendar and made it happen because this is fantastic. What a great set. Thank you so much, everybody. Have a great rest of your day, and we'll see you at the BrickTalk. See you later. Bye, guys. Bye, everyone.
Thank you.